Hello, I'm Tom Wade, President of Ferrate Solutions, and this is a recording of a presentation that was made through Isle Utilities in early March of this year. Isle Utilities is a consultancy based in Amsterdam that provides new and innovative technologies for a large client base, principally of very large industries worldwide. This year we were selected in the top 5 to be part of that presentation. This is our presentation that we made. Okay, so we're following the format that Isle Utilities require for the presentation. So we're presenting things that maybe aren't what we would do normally, but nevertheless they're here. So the first thing is the company itself. Ferrate Solutions is a company in the U.S., is the first to provide engineering expertise and materials for applying the Ferrate technology to large-scale water and wastewater problems. We have 6 full-time technical staff and a world-class equipment manufacturing company here in the U.S., in Florida specifically. I'm the founder and CEO. Our Vice President for International Affairs was also on this presentation, Mr. David Liang, and you see his email there also if you're interested in corresponding with us. So what is the technology? Ferrates are basically high-valence iron compounds, and they're oxoanions, meaning it's just iron and oxygen. Iron is present in a high oxidation state, usually higher than 3 or 4, even 5 or 6. We utilize iron plus 6. This is a breakthrough chemistry. We've done this through modifying the synthesis procedure as well as doing the chemistry on its applications. And the largest part of the breakthrough has been that we have developed chemistry to utilize normal feedstock chemicals that are common all over the world. So nothing fancy about the feedstocks. We utilize plain commercial compounds, pretty much available at all and present at most water and wastewater plants around the world. On the right side here you'll see, your right, my left, sorry, you'll see a schematic of a Ferrate synthesizer, and basically you can see it's a simple concept. The 3 chemicals needed are added: a ferric compound, an oxidizing compound, in this case bleach, and a caustic to stabilize the ferrate when you produce it. Ferrate is produced during this reaction, and it's then passed on to a mixing storage tank here that allows the compound to be fed directly into a water or wastewater treatment scheme on a continuous basis. So this is a batch process. This is a continuous feed. This is a typical Ferrate synthesizer. So what's the chemistry look like? Here we see the stoichiometry of what's going on. Iron plus 3 being reacted with an oxidant, in this case bleach, forming the ferrate. You can see how it happens. Here is the caustic and the bleach being mixed. Once the ferric is added, it's converted immediately to iron 6, and the more you add, the more concentrated you make the solution. So after a while you have a very strong concentration of ferrate in solution. This is what happens when the ferrate is put in the water. Ferrate iron 6 immediately starts decomposing to iron 5, 4, ultimately down to iron 3, and forms the hydroxide. So all of the processes that go on then that we are used to in water and wastewater treatment, that is disinfection, oxidation, and finally coagulation, all occurs with this one addition. So this compound is able to provide oxidation, disinfection, coagulation in one chemical. Nothing else like it on the planet. Okay, so what are the novelty and advantages of this technology? Well, first of all, it's a major paradigm shift in the fact that we're talking about oxidation plus coagulation in one treatment. Because the only component remaining in the water is the ferric compound itself as a hydroxide, the amount of sludge produced is very small because the iron is small that's being added. And energy-wise is extremely efficient. For example, This picture is a ferrate synthesizer currently operating here in Florida. This machine only uses 80 kilowatts of electricity, and this will make almost 300 gallons per hour of water, or something like 1 cubic meter of ferrate. Sorry, this is a ferrate. 1 cubic meter of ferrate per hour in this machine alone, and you can see it's trailer mounted. So this is a mobile unit. It makes an awful lot of ferrate. This can treat very large volumes of water, just this system itself. So the benefits to industries that we were addressing, chemical, oil and gas, of course, and other large water users in the industry, is that it's a simple treatment with much lower O&M costs, and it reduces redundancy. Because ferrate is such a broad treatment chemical, we find that it can treat many different kinds of waste streams. Therefore, a large industry could use it within their industry to treat many of their schemes, rather than having to go out and find individual unit processes to treat different waste streams that they have. That's the advantage of it. So applications and case studies that we have, I'll just put a few up here. Many pilot systems have been run up to about almost 4,000 cubic meters a day. All of domestic wastewater, drinking water, wastewater treatment plants, power plants, hazardous waste, sludges, oil and gas, and industrial waste have all been tested. Okay, so its reactions are well known. Its ability to treat all of these waste streams are well known. So a few examples. Here's some treated water. This is for a dye wastewater. This is in the Middle East, and the plant was a fabric manufacturing plant. You can see the effluent here has both an intense blue dye, and if you look close, you can see all of the suspended solids that are in there. With the optimal treatment of ferrate, this one, you can see it's destroyed the dye and has settled the solids out in a small dewatering amount of solids. This factory is waiting to get a ferrate treatment system once we can get back over to the Middle East. This is frack water, the oil and gas industry. This is from the produced water and fracking. Here it is, what it typically looks like coming back out of the ground. Here it is treated with ferrate. The idea, of course, in fracking is to treat the water so it can be reused as much as possible before it's stored on site, and then treated after that so that it can be reused off-site in some degree. Ferrate can treat all of that. This is an example of what it'll do with it. This example is treating sludge from wastewater plants. This is Houston, Texas. 12 wastewater plants discharged their sludge to this facility. They needed to treat it to land apply it, and ferrate could do it. So here's the system coming off the truck, not very big at all, already portably transported. And this system was able to deodorize, disinfect, raise the pH of the solids, and with a little bit of polymer able to produce a Class A biosolids that could be directly land applied. And this was the goal, and this worked. Just a couple of pieces of data. This one, again, in the oil and water industry, or gas and water industry. This is a polymer water. This is a high viscosity water from a processing plant in Europe. And this is treatment with ferrate. So this is the amount of ferrate added. This is the viscosity of the water to be treated relative to tap water. These numbers are tap water. So as you can see, by the time we dosed at about 10-15 milligrams per liter, we had reduced the viscosity to that of tap water at that low dose. These data are from the Middle East, and these are radionuclide data points. As you know, deep aquifers in the Middle East have a lot of natural radioactivity in them, prohibiting them from being used for drinking water. This was a recent test we ran in our pilot treatment system, and these are all of the normal types of radioactivity being measured, from total beta, total alpha, radium-226, radium-228, and uranium, and you can see all of them coming down. This is their relative radioactivity versus a dose of ferrate. So as this gets out to a medium dose of ferrate, we've reduced basically all of the radioactivity in that water allowing it to be utilized for drinking water. An operating project that's underway right now. This picture shows a muck dredging site. That muck means organic material that's in the bottom of lakes and lagoons. This is a coastal area in Florida that's attempting to remove nitrogen and phosphorus in the water excuse me, to stop algal blooms. The first move is to remove the sediments, which are feeding nitrogen and phosphorus into the overlying water. This is a common operation underway in Florida and coastal waters. This site is a temporary site built to handle the muck that's being pumped in from a dredge. Here it is coming in. That's what it looks like. Not very nice stuff. It goes through settling ponds here on site. Polymer is added and the sediment is reduced and removed, dewatered, and trucked off site. However, all of the water that's here that's transporting the sludge now has to be treated because the majority of the nutrients that were in the muck are now in the water. So that's why Ferrate was called to see we are the only chemical that can remove both nitrogen and phosphorus. And we were asked to treat this, which we've been doing now for over 9 months. Everything you see in this picture, except for the backhoe, is the Ferrate treatment system. All of it. The tanks, the filters, the frac tanks in the back. That's all the Ferrate system. That system is there supporting about 4,000 gallons a minute of flow of that stuff. So this is been running now going on 9 months. Here's a Ferrate synthesis system that's out there. Here's some of the data. This is for phosphorus. We have the same figure for nitrogen versus many months here, 4 months, total phosphorus. The blue is the incoming concentration of phosphorus. The orange is what's going out after treatment with Ferrate. So you can see pretty much almost 85–90% of the time, this is keeping the phosphorus actually below detection. When you can see the incoming concentration can be as high as 10 milligrams per liter, depending on the day and what type of muck they're bringing up. So this is a very difficult project, and Ferrate's handling it. So we'll look at the costs a little bit. Everyone wants to know, well, how much does this cost? There's many ways to look at costs. I thought I'd put up a typical total engineering evaluation of a project, including both capital and operational costs. This is for a wastewater plant in New Orleans. This typical plant excuse me, was destroyed in hurricane, unless you were in a hotel, Hurricane Katrina, and they wanted to, when they rebuilt the treatment plant, they wanted to really reuse the effluent to regrow the bayou that had been destroyed when the hurricane came in. So they needed to have the effluent disinfected and be safe. They needed personal care products and endocrine disrupting compounds to be removed. They needed the odor to be gone, and they need the total solids to be gone. They didn't care about the nutrients, even though those were going to be removed anyway, except we can leave the phosphorus in if we don't precipitate it anyway. This is what they needed to have done. They evaluated the usual cast of characters, or not usual, the rest of them, to treat that effluent. And they put Ferrate in there. Tulane University worked on this for 1.5 years to evaluate these. They determined that these could all sort of do it. This is not a fair comparison. These are just oxidants, chlorine, UV, ozone. They're one-trick ponies. Ferrate's doing coagulation, it's doing disinfection, it's doing all kinds of things, including the PCPs, which these can't do. So it's not fair to compare them, but they were done. This comparison in cost was done by a very large firm, Black & Veatch. That's an international consulting firm. And looking at both capital costs, operating and maintenance costs, and you can see here all of the different components, a typical engineering evaluation of costs, comparing these entities. Also point out, this is a very large plant. 800,000 cubic meters a day is a lot of wastewater. That's a biggie, okay? Anyway, that means the numbers are going to be big. So if we look here at, let's say, the present worth, which is a total for the 15-year operation, the normal moniker they use. Here's Ferrate in at about 85 million, and you can look at the, even just plain chlorination By the time you get up to, if you want to look at making it on site, you're at twice the cost of Ferrate. UV, ozone, forget it, they're ridiculous. Okay, it shows that Ferrate is not only the most cost effective, it's like by way the most cost effective way to treat things, and they're not taking into account many of the things that Ferrate will do with this waste that these other treatments cannot do. Okay, so what's the status development and way forward? As I said, this is a format for Isle Utilities, and the industries that we presented to want to know where we are and where we're going, because they're very interested in partnering with us. So once again, we're a US-based company with the technical expertise and manufacturing capacity to design and produce Ferrate treatment system. Our current business model, is to concurrently initiate direct sales of equipment and systems around the world, but more importantly to form partnerships and licensing with entities, in the case of this presentation, large industries, especially oil and gas industries, that could use this technology for treating their many wastes. It's important, and this is highlighted, that Ferrate is the first to market. So what we do as a business model is, when you're first to market, it means you have no competition. It means you don't have to worry about things like somebody stealing your IP. You don't need to worry about somebody undercutting you. No place in the world has Ferrate. We have a complete, clear palette to work on worldwide. And that, from a business point of view, makes a huge direction in where you go. When you've got no competition, it isn't saying that I'm a little bit better than this guy and that compound and a little bit better. There's nothing, no other Ferrate in the world. So we're looking at a rapid global market growth. In fact, we already have it started, and we will then take the next steps, and that will be that we will compete with all conventional water and wastewater treatment technologies. So Ferrate is going to compete with everything else. It doesn't have to compete with anyone else making Ferrate. It doesn't exist. So we'll compete with all the regular systems like you saw before, and we'll do very well. We intend to develop relationships, I said, and partnerships. We've already started forming them internationally. We have 5 or 6 projects already globally sitting waiting for the virus to go down, that are going to enter into some sort of regional partnership. And we can now do treatability in our own laboratories, pilot testing immediately, and we intend to couple with industries as well as regional partners in opening partnerships around the world. That's our business model. Thank you very much for listening, and God bless.